Find the equation of the form y is equal to ax squared plus bx plus c using matrix inverse when you have a product of two matrices which equals to 11, negative 76, and negative 121 matrix. So how do we use an inverse? Notice that to solve for A, B, and C matrix, we have to somehow get rid of this matrix on the left. So if we find the inverse of this matrix and multiply that inverse to this matrix, it will become identity matrix, and identity matrix times the matrix consisting of entries A, B, and C will just give you entries A, B, and C. Okay? So you have to find the inverse of this, multiply it to this matrix, and then you get rid of this matrix as a result. But remember, when you multiply the inverse on the left side, you have to multiply the inverse on the right side, right? Right before on the left side of this matrix. That way we will solve for A, B, and C. Okay, so what I mean is if you let A be equal to this matrix here that's given 20, 2, negative 1, negative 35, negative 3, 1, negative 40, negative 4, 1, then if you multiply, notice that the inverse times the given matrix A will be equal to identity. Okay? And notice that if we let A, B, and C, if we let P, basically P be equal to this A, B, and C matrix, then this is equal to identity, because that's the product of the inverse times the original matrix A, identity times the P, which is equal to P, right? So I'm just showing you algebraically what I said before using words. So we will have solved for A, B, and C if we multiply A to the negative 1, the inverse by the original, that gives us identity matrix, and then identity times the P, the third matrix consisting of entries A, B, and C, is equal to the matrix itself, A, B, and C. But you have to do the same thing on the right side. So that would give us the inverse being multiplied to Q. And Q, of course, you will say Q is equal to this matrix, 11, negative 76, negative 121. Okay? And that would be the answer, the inverse times the Q, so the inverse of this times this matrix would be equal to the A, B, and C matrix. And that way we will easily find A, B, and C. Okay, so let's do that. So the first thing we need to do, we need to find the inverse of this. So the next question is, how do we find the inverse? How do we find the inverse of this? Well, that's a good question. We also going to use the identity matrix again to find the inverse. So what you're going to do, you're going to first write the entries 20 to negative 1, negative 35, negative 3, 1, negative 40, negative 4, 1. And identity matrix, you're going to write 1, 0, 0, 0, 1, 0, 0, 0, 1. So identity matrix is always a square matrix such that it's written in reduced row echelon form. Okay? So basically you have leading ones in each column and each row, right? So in each column and each row, there's no, the one does not appear more than once, right? One appears only once in each column and each row. That's the reduced row echelon form, and that's a square matrix always, and that is the identity matrix. So identity is helpful because because we need to reduce this, the given matrix A, to reduced row echelon form. So we want to transform this into this. So by default, by the same set of operations that we use to transform this matrix A into the identity, we'll have transformed the identity into the inverse that we will need to find. And inverse, of course, will be a 3 by 3 matrix, just like the original A matrix is. Okay, so that's why I wrote them together, because by the same set of operations that we transform this matrix A into the identity matrix, this identity will be transformed into the inverse of A. All right, so let's do that. So the first thing to do is to make, as you can see, this is a good model of what should be done. Obviously, the first entry in the first row must be a leading 1. So we have to divide this 20 by 20 in order to transfer this number into a 1. Right, so the operation that we're going to need is 1/20th times row 1. 1/20th times row 1. That will make sure that this will become a 1. But the other entries in the entire row will need to be divided by 20, as you can see. Even the identity matrix, right? Because we're using the same set of operations for the A matrix and for the identity matrix. All right, so what happens is now, notice that the second and third row are just copied over. They don't change. Be sure you understand that. We're only working on row 1. So we'll just copy them over, 0, 1, 0, -40, -4, 1, 0, 0, 1. And this is, now this changes, right? This becomes a 1. This becomes 2 divided by 20, which is 1/10. And -1 over 20. And this is 1 over 20. This is 0 and 0, right? Because 0 divided by 20 is still 0. Okay. So now that you have that, look what happens next. We need to make sure that these two are zeros, right? Because look at the identity matrix. We have zeros below the leading 1 in that column, right? Because there should be nothing but zeros in that column, right? Because the number 1 appears only once in each column, right? So 0 and 0. How do we make this a 0 and this a 0? Well, we have to basically add positive 35 to this row. That way it will become a 0. And we have to add positive 40 on this row. That way this -40 becomes a 0. Right? So we're going to say row 2 plus 35. Now how do we add 35? We're going to use that 1 in row 1, right? So 35 times row 1, and row 3 plus 40 times row 1, right? That makes sure that we will get what we need. Okay? So notice that the first row now is copied over without any change because we're working on row 2 and 3. Right? So we just copy it over. 0, 0. So this becomes a 0 now. We can safely just write zeros in that column. Now this one we have to be careful. So -3 plus 35/10, right? Basically that's what we're doing. And as a result, what you should get for this, for the second entry here, should be 1/2. Okay, and I'm not going to delve into algebra. You should do this in your own practice. You should get a 1/2. When you get your fraction, you should also simplify to get 1/2. Now this entry is going to be what? 1 plus 35 times this, which is basically minus 35 over 20. 1 minus 35 over 20. Simplified should give you, if you use algebra correctly, minus 3/4. Now this is going to be more complicated as well because we have to keep working on that row as well. So 0 plus 35 over 20, pretty much based on that. 0 plus 35 over 20, which simplified gives you 7/4. Now this, of course, is not going to change because there's a 0. 35 times 0 is still 0. So 1 plus 0 is still 1, right? That doesn't change, and 0 doesn't change as well, right? Because the top 0 doesn't do anything. As you can see, it's going to be 40 times row 1 for this row, right? So minus 4 plus 40 over 10 is going to be minus 4 plus 4. That's easy, right? That's just 0. And this one is 1 minus 2, right? Because 40 divided by 20 is 2, so 1 minus 2 is -1. Now, this is 1 plus plus 2, right? 40 over 20 is 2. 0, so 0. 0 plus 2 is 2. That's easy. Now that doesn't change, so these two do not change the values, right? Because the 0 does not change anything. So we just write 0 and 1. Okay. So now, as you can see, this column is clear. The next column, we need to make sure that this turns into a 1 first, right? Because that will be the next leading one, right? Because according to the identity matrix model, the next row will have a 1 in the middle, right? So we need to make this a 1 instead of 1/2. How do we do that? We multiply this row by 2, right? Because multiplying this 1/2 by 2 makes this entry a 1. All right, so we're gonna say 2 times row 2. And I'm gonna make the next set of entries here. So 2 times row 2. So that means the first row and the third row are written as they are. No change. 1, 20, 0, 0. So I'm going to write third row as it is. 0, 0, negative 1, 2, 0, 1. Okay. So now this turns into a 0. This turns into a 1. So twice everything here. Twice negative 3/4. Going to give you negative 3/2. Twice 7/4 gives you 7/2, right? And this 1 times 2 is just 2. 0 times 2 is still 0, right? So far this is what we get. Now what's going to be next? Let's notice what's going to be next. So underneath the 1 we already have a 0 like the identity matrix should, but on the top we don't have a 0, right? As you can see, the top should be a 0. So we need to not multiply this by 10 because this needs to be a 0 and not a 1. We need to subtract 1/10, right? So how do we do that? We're going to do row 1 minus 1/10 times row 2, right? Because 1/10 times 1 is 1/10. And that should make it okay. So that means row 2 and row 3 can be written as they are. They don't change. 7, 2, 2, 0, 0, 0, negative 1, 2, 0, 1. So this, notice that it doesn't change the previous work, this operation, because this guy is a 0. 1/10 times 0 is still 0, right? So 1 minus 1/10 times 0 is still a 1. That's the beauty of it, right? That doesn't change. And that's exactly what we want. We don't want to change our previous column that we already worked on, right? So 1/10 minus 1/10 times 1, which is 0. Good. Now this will look like this picture. And negative 120, lots of signs. This is pain. This is a pain. So negative 120, minus, so that would be a plus, right? Plus 320. Negative 120 plus 320 is 220. 220 is reduced as 110. So that should be clear. Now here's another pain. 120 minus 720, which is negative 620, which is negative 3/10, right? That should be clear. 0 minus 2/10. 0 minus 1/5. Beautiful, negative 1/5. 0, again, that 0 doesn't change, right? So we write it as 0. Good. So now the second column clear. Now we have to make this entry in the third row, like the identity matrix here, a 1. This is currently a negative 1. So we have to multiply the entire row by negative 1 to make this a 1. Right, so negative 1 times row 3. Okay, so negative 1 times row 3. The first and second row will be copied. Negative 310, negative 15, 0, 0, 1, negative 32, 7, 2, 2, 0. So this Easy, right? Just multiply all the entries by -1. You negate whatever was positive. You make positive whatever was negative, right? Like that. Okay. So now, as you can see in the identity matrix, the 2 zeros on the top of that one below should be there, right? But right now we don't have them there. So we have to do something to the entire row 2 and row 1 and use that 1 there according, together with these numbers to make sure that these become a 0. So what do? We should do row 1 minus 1/10 row 3, right? So row 1 minus 1/10 row 3 gives you 1/10 minus 1/10, which would give you 0, right? Now row 2 should not be minus because it's already a negative. It should be plus, right? It should be plus 3/2 times row 3, right? And that should give us the correct assessment of what should be going on there. So we copy over the row 3 because that doesn't change yet. 0, 0, 1, -2, 0, -1. So row 1 minus 1/10 row 3. So let's see what we get. This should be 1, 0, 0. All right, and the next is going to be a little painful. So -3/10 plus, right, because of two negatives here, plus 2/10. -3/10 plus 2/10 is -1/10. All right, that's fine. -1/5 minus, now this is a 0, right? We immediately copy in the -1/5. That doesn't change. Now 0 minus 1/10. This is a minus already, so plus. 0 plus 1/10 is positive 1/10. Okay, now the second row. Row 2, so this doesn't change. And why? Because these are zeros, right? Now this will change. This will be what? This will become a 0, right? Because you're adding 3/2 to the -3/2. That becomes a 0. Bingo, we already have an identity matrix on the left. And when we complete this, this will be an inverse that we find, the a to the -1. This will be an inverse once we complete this row. So let's see what this is going to be. This is going to be 7/2 plus 3/2. So there's a minus, so 7/2 minus 6/2. 7/2 minus 6/2 is 1/2. That's good. That 0, make sure that we copy that 2, doesn't change. This will change. So 0 plus, there's a minus, so minus 3/2. 0 minus 3/2 is minus 3/2. Bingo, we just found the inverse. Very good. So as a result, the inverse is what? The inverse matrix is this. Is the former identity matrix that we've transformed into the inverse. Minus 1/10, minus 1/5, 1/10, 1/2, 2, -3/2, -2, 0, -1. Okay. So now that we have the inverse, we can solve for A, B, C, right? Because we know that this inverse times the original matrix A will give us just simply the P, and the P was ABC matrix, right? But remember that we have to multiply, in order to solve for P, is going to be equal to the inverse multiplied by the Q, right? So we can say then the matrix A, B, and C that we have. So matrix A, B, and C will be the product of the inverse times the Q matrix, times this matrix on the right side, right? So it's going to be the inverse. Let's copy that down. Minus 1/10, minus 1/5, 1/10, 1/2, 2, -3/2, -2, 0, -1, times the Q matrix, which is 11, -76. Write that better. and negative 121. So now that should be easy, right? Because we're going to basically use the product of these matrices and find the resulting entry for A, B, and C, right? So how do we find the A? So A is going to be what? A is going to be negative 110 times 11 plus negative 15 times the negative 76 plus 1/10 times negative 121, right? And I'm not going to review how to do this. Just watch my other videos on matrix operations, namely matrix multiplication. You'll see what it is. So 1/10 times negative 121. So that should give you negative 11. And I'm going to use the LCD right away. So it's going to be what? It's going to be 76 times 2 is negative 152. But there's a positive because 2 negatives, so plus 152. And then minus 121. They will have the same least common denominator of 10. So that should give me what? That should give me negative 132 plus 152 is 20 over 10, which is 2. Okay, so the A value is 2. We just found the A. A value is 2. So we can circle that. That's one value we found. Now, the second value will be the B value. Now, the B value is going to be found the same way. So you're going to take the 1/2 times 11 plus 2 times negative 76 plus negative 32 times negative 120. Notice that I'm using the same row for the B, right? Just like I used the row for the A entries. 1/2 times 11 plus 2 times negative 76 plus negative 32 times negative 121. Okay, and that should give you, let's see, the LCD would be 2 here. So 11, so let's just add 11 plus negative 152 times 2, 304, right, 304, but there's a minus, so I'm going to have to use a minus there, so minus 304 plus, because of 2 minuses, plus, now this we can leave alone without multiplying by 2 because this is a denominator 2 already, right? That's the least common denominator for all of them. So 121 times 3, because we're dealing with positives, is going to be 363. 363 divided that by 2. So what we should get is, let's see, 374 minus 304 is going to be 70 divided by 2 is 35. Beautiful. So the B value is 35. B value is 35. Now finally the C value, right? The C value is going to be taking the last row of this. So minus 2 times 11 plus 0 times negative 76, so we can disregard that. And well, actually the plus makes sense because the last product, negative 1 and the negative 121 gives you a positive, right? So plus 121. So that should be easy. 121 minus 22, which is 99. Beautiful. So we have found all three constants successfully. So C is equal to 99. All right. So as a result, the equation that we need is going to be this. Y is equal to x squared plus bx plus c, right? A is equal to 2. B is 35. And then C is 99. Okay, so this is your answer to the required problem. So I hope this was helpful now that you probably understand how inverses work and how they help us formulate the solution. In this case, the solution was to find the constants a, b, and c to the given quadratic equation using inverses of the left matrix. Thank you so much for watching again. I'll see you in the next video.